So hi everyone, welcome to Electronics Techie. In this video, we are going to discuss about transistor. So what is the definition of the transistor? How to define, like it is one of the semiconductor device, or the thing which are going to be designed or made with semiconductor component. So the semiconductor device, what is the use of the semiconductor device? It can amplify or switch the signals. So what are the electronic signals we have? It's going to be amplify or, which is nothing but it can be weak signal, we can convert it into the strong signal. So like that we are going to be amplify the signals or switch the electronic signals. So the word comes from the transistor is transfer plus resistor. So the signals which are going to be passed cross the resistance. So that's thing, by this transfer plus resistor we get the transistor word. Okay, so this is the one of the fundamental block of the modern electronics. So coming to the classification of transistor, so there are the two types of classifications in this transistor. So one is BJT, bipolar junction transistor. So another one is FET, field effect transistor. So in BJT we have again classified into NPN and PNP transistors. So coming to the FET, it can be classified as JFET and MOSFET. So JFET is nothing but junction field effect transistor. So in MOSFET, it is a metal oxide semiconductor. So FET is nothing but field effect transistor conductor. Okay. So next JFET means depletion N channel and P channel. In MOSFET, you have depletion and N channel and P channel. These are the classification of FET. So our main concept today is about BJT. So BJT have two types, NPN and PNP transistor. So NPN. So collector is of N type, emitter is of N type, base with P type. So in PNP transistor, PNP. So the collector and emitter is the P type and the base with N type. So coming to the difference between these two, you can represent with arrow. So the arrow which are going to represent in the transistor is the main role. So here the arrow is like P to N, means we know that the flow of current is from P type material to N type material. So the arrow mark will be represented like this. So P type to N type, the flow of current will be there. So here the flow of electrons is from, the flow of electrons is from P. The flow of current is going to be from P type to N type. So in PNP transistor, there will be a flow of P type to N type. So you can represent the arrow mark like this. Okay. So coming to the picture, there is a NPN layers in the NPN transistor, means NPN layers will be there. So the current flow from the collector to emitter. So what will happen? The flow of current is from collector to emitter. So base current IB turns on the transistor. So whatever the input current we are going to apply at the base is going to be the on the transistor at particular current. So commonly used in the amplifier circuits. We use this in the amplifier and digital circuits. So arrow is away from the base. So what are the arrow which are going to represent towards the emitter and from away from the base? So in PNP transistor, there is a P layer, N layer and P layers. So the current flow from emitter to collector in this PNP transistor. We know that there is a flow of current is from emitter to collector. So base current turns on the transistor. So here also the input voltage is base current. So it can be on the transistor. It may be used less, means the usage of the PNP transistor compared to NPN transistor is less. So it can be used in some specific analog circuits. It will be used in digital circuits, whereas it is used in analog circuits. So the arrow which are going to represent this PNP is towards the base. See, the towards the base, the arrow is going to be represented. So evaluation of transistor. Now we are in the technology of GAFET, FinFET like that. So what is the previous technologies we are going to use? So first we are going to use point contact BJT. Means in previous olden days, we use the technology of point contact BJT, which are invented in Bell Labs. So here we are using metal point contacts on germanium. By contacting the metal points, we are going to be on these things. And coming to the junction BJT, next thing now we are going to discuss. So this is the bipolar junction transistor. So next one is MOSFET. So MOSFET is a metal oxide semiconductor field effect transistor. Discuss later. So then after we move to the CMOS for some advantages. And next we move to the FinFET and GAFET. Now we are explaining the BJT, and upcoming videos we move to the MOSFET, CMOS and FinFET and GAFET, what are the things, what are the advantages we are discussing. So till now BJT. So BJT, what is the full form of the BJT? So bipolar junction transistor. So bipolar, why you call it as a bipolar means the flow of electrons or the flow of current is due to the both majority and minority carriers which are present in this transistor. So that's why we call it as a bipolar. So means it contains two polarities, so positive and negative. So coming to the junction, in BJT we have two type of junctions. So you see here if there is a BJT emitter base collector, if there is emitter base collector. So this is the N type. So if I consider NPN transistor, it is NPN. So for PN junction diode, there is a depletion layer. Then some junction is going to be formed between the different type of materials. So here there is a emitter based junction. Here is the collector based junction. Sorry, this is the collector based junction. So there are the two types of junctions we have to represent. So coming to the transistor, we already discussed of the transistor definition before slide. So coming to the characteristics, there is a three terminals, emitter, base, collector in the BJT. So it is a current control device. So why you are going to call it as a current control device? So by applying the small input voltage, you get the output voltage from the circuit. So what are the transistor we have? So sorry, the symbol of the, I just do the rough diagram. The symbol of the transistor is, so the applied base voltage is low, but the output power going to be collected is like large. So by using small input voltage, we are going to control the output current. So that's why it is a current control device. By current, we are controlling the output current. So there is a two junctions we already discussed, emitter base and collector base. So coming to the structure and construction of this BJTs. So NPN transistor, here explaining NPN structure. So try your own by PNP transistor. So if you have any doubts while you are doing the things with PNP transistor, so just comment for it. But now in this video, I am discuss about NPN transistor. So coming to the NPN transistor, the emitter is with N type. So base with P type, and again collector is with N type. So see the doping concentration. So how you are going to get this N type and P type? We already discussed now. So by doping the pure silicon with pentavalent impurities, we get the emitter. So by doping the pure silicon with trivalent impurities, we get the P-type materials. By the doping, we are going to get this type, but the concentration of the doping for emitter is more heavily doped. For base, it is lightly doped. For collector, it is moderately doped. So coming to the doping comparison, see here, emitter is a heavily doped and base is lightly doped and collector is moderately doped. Why we dope like this only means the reasons are these. So must supply large number of carriers. So the emitter is going to be supply large number of carriers. So that's why doped with high concentration. So base. So it is lightly doped. Why? If you doped with more the things, so the electrons which are trying to move towards the emitter to collector, so they are recombined with the holes only. So that's why how to decrease this concentration. By decreasing this concentration, the more number of electrons move towards the emitter to collector, the flow of current from collector to emitter will be more. So why collector means a collector collects carry large area to dissipate heat. So it requires large area compared to emitter and base. The collector has large area. Why? The electrons which are going to be grabbed by the collector, it dissipates some heat. So where that one you have to moderately dope and the space will be more compared to the emitter and base. So emitter has less medium width and base has less width. So coming to the BJTs as a two depletion regions are formed. There is a two junctions means there is a two type of depletion regions are going to be formed. So due to the narrow base, the width of the base will be narrow and the concentration which are going to be doped emitter is high. So that's why the transistor is going to be conducted by these cases. So why you are moving to BJT to MOSFET, we discuss later. So first we have to know the operation of the BJT. Here I will come see. So emitter, base, collector. Okay, emitter, base, collector. So these are the terminals: base, emitter, and then collector. Emitter, base, collector. So we know that there is a three type of region. So what are the three regions in the BJT? The BJT is going to be operating three type of regions. So one is active region, So second one is saturation region. So third one is cutoff region. So these are the three regions we are going to be operate. So emitter and base is going to be, what are the emitter base is going to be forward bias. So this is the NPN transistor I am considering. So negative, it can be connected in forward bias. So coming to the base and the collector is going to be in reverse bias. So that's why I connect like this. Okay. So NPN transistor. So now what will happen means, so the electrons, so this negative charge is repelled by this negative charge. So the electrons are trying to move towards the junction. So some of the electrons are recombined here and remaining nearly 5% of electrons are recombined at this base type. So remaining 95% of electrons are trying to move from emitter to collector. The flow of electrons are more. So means nothing but the flow of current from collector to emitter will be more in active region. So like that we say the things. So I will write here what is the things which are going to be done. So for active region, the emitter base junction should be forward bias and the collector base junction should be reverse bias. So coming to the saturation region. So again consider the BJT. So NPN. So now what will happen means emitter base should be forward bias and the base collector also to be forward bias. So base, emitter, collector both should be the forward bias. So what will happen? So both the which are the things the electrons are trying to move towards the emitter to collector as collector to emitter. So both are trying to move towards the junctions. So what will happen? There will be recombined and the current which are going to be get in this particular output is going to be constant. So there is no further increment in the output current by using in the saturation current. So I will write written here. So for saturation, what will happen? Emitter base and collector base both are will be the forward bias. So for cutoff region, so NPN transistor, both are in the reverse bias. So what are the base in the collector and the emitter? Both are in the reverse bias. So what will happen? The electrons which are going to be attract towards this positive charge and the collector electrons are trying to attract this positive charge. So there is no flow of current electrons towards the emitter to collector. So there is no electric flow also. That's why the transistor is in off state. So the transistor is going to be off switch. So cutoff region. So whatever the emitter base and the collector base both are in reverse bias. So then it will act as a switch off condition. So saturation region it acts as a on switch. Okay. So like that the transistor is going to be on switch and action switch and in active region it is going to be act as a amplifier. So it is going to be amplify the signals. So these are the operational regions of the BJT. So what are the regions? Active region, saturation region, and cutoff region. So emitter base junction should be forward bias and the collector base junction should be reverse bias. Here the both the junction should be forward bias. Here the both the junction should be reverse bias. So active region is acts like amplifier and saturation region is act like on switch and cutoff region is acts like off switch. So these are the things the BJT is going to be work related to NPN transistor. So the operation of the PNP transistor is also same, but the carriers, the majority carriers, the flow of current is due to the holes. Here the majority carriers and the flow of current is due to electrons. So in PNP the current is due to the holes. Okay. So what is the disadvantage? Why move to the MOSFET and FET? So BJT is a current control device. So it has large power consumption compared to the MOSFET. So MOSFET is only the voltage control device. So that's why less power is going to be required as compared to the BJT. So CMOS has a less power dissipation compared to the BJT and MOSFET. So that's why you move to the BJT to MOSFET. Till now, what we are going to discuss is there's a two main type of transistor, BJT and FET. So coming to the classification, again there BJT is classified into PNP and NPN transistor and FET into JFET and MOSFET. And again there are some classification we discussed. Then next, what is BJT? What is the full form? How it is going to be we discuss. So again, there's a three type of terminals: base, emitter, and collector. So technology evolution, how the past to previous days, the technology is going to be developed by BJT, MOSFET, CMOS, FinFET, GAAPET, all the things we discussed. So why MOSFET means it is a voltage control device, it get less power and the size also is going to be less compared to the BJT, and the complexity is also less compared to the BJT. That's why I move to the MOSFET, and also discuss the operating regions and how it is going to be works, like amplification or switch or on, switch or off, switch, like that we discuss. So till now, if you have any doubts, you can comment for it. So from this video, you get the complete detailed understanding of the BJT. In upcoming videos, we discuss about some other technologies like MOSFET, and CMOS technologies. So it is the basic thing you have to understand. So don't hesitate to ask anything in comment section. Thanks for supporting and